By the end of this topic, you will be able to list the questions one should answer while exploring categorical variables. Find frequency distribution of unique values of a categorical variable and visualize relationship between numerical target variable and categorical variable with the help of bar chart. So we continue our journey of understanding and preparing our data for modeling. And now we will analyze the last segment, which is the categorical or string variables. We will be reusing the transformed housing data which we had obtained in the previous topic. So let's use the output from the transformed housing data.info code to help us identify all the categorical variables, that is, variables with data type as object one by one. The variable ID won't be required as this is just an identifier for each house and won't add much value in our analysis. So we will be dropping this variable, and for that we write the code as shown on the screen. Now for better understanding, the categorical variables, or we can say variables with data type as object, let's identify them and list them down. Just like we did for numerical variables, we seek answers to the question as shown on the screen while exploring categorical variables. As we told you earlier, we will be exploring one variable at a time, so that's what we are going to do now. Let's examine the variable condition of the house first. Now, for the answer to the first point, we know that the variable condition of the house represents what is the condition of the house. Now for eyeballing only, the kind of values this variable contains, let's see the first 10 values of this variable, and for that we write the code that we had learned to write previously. From the first 10 values, we infer that the condition of the house is recorded as fair for 9 of them and 1 of them is in excellent condition. Let's move to the next point and find out the unique values for this variable along with their frequency of occurrences. This essentially means what are the different condition types of houses in our dataset and how many houses are there in a particular condition at the time of sale. For that, we use the function value_counts, and the code is transformed_housing_data condition of the house dot value_counts. From the frequency counts table, we can see that there are 5 levels, that is fair, good, excellent, okay and bad, in which the condition of the house is defined. Here, a quick thinking question for you. Now that you know unique values for this variable, is it an ordinal categorical variable or nominal categorical variable? Yes, this is an ordinal categorical variable as there is a sense of order among levels where excellent is greater than good, good is greater than fair, fair is greater than okay, which is greater than bad. We can also see that majority of the houses are in fair condition while very few houses are tagged as being in bad condition. Next, we want to find out if there is any relationship between the categorical variable and target variable. That is, how does the target variable change with the change in values or levels of category variable? We would first try to see this visually and then mathematically. For visual representation, while we cannot use the scatter plot as we did for numerical variables, since for scatter plot both the variables, say x and y, need to be numerical, but we can look at average value of sale price across different levels of a categorical variable in the form of a bar chart. For this, we write the code and get the output as shown on the screen. First, we grouped the data based on condition of the house and then plotted a bar graph based on the mean of sale price. For the bar graph, we are using the library matplotlib. For better visualization, let's reorder the bar chart we have for average sale price in ascending order of average sale price. For that, we have added the function sort to the previous code. Similarly, we can visualize the relationship of sale price with other categorical variables, that is waterfront view, ever renovated, and zip code. Now as you can see, we do see that house prices vary across zip codes as we had discussed previously. Though this may not be a numerical relationship, that is, nearby zip codes need not have a similar price, which is why we had transformed this variable into a categorical variable. So this was about visual representation of relationship between a categorical variable and a target variable, which is numerical in nature. Now you must be wondering that if, just like we had studied correlation in previous topic to find out relationship between two numerical variables, there exists a mathematical or statistical way to compute this between a categorical and a numerical variable also. And yes, there is a method of finding out whether a categorical variable is having an impact on the numeric variable, and this method is called ANOVA. But we won't be able to quantify the relationship. We can just tell whether it is having an impact or not. Now you must be curious to know more about ANOVA. Well, that would be our topic of discussion in the next tutorial. See you then.